Right now, across global networks, AI agents are booking flights, executing code, and pulling customer records. These systems leverage large language models to take direct, autonomous action in the real world. But these systems suffer from a severe limitation. Because large language models are stateless entities, an agent's memory is confined to a temporary context window. The moment that window fills up, or the session ends, the agent resets. It has the computational power of a supercomputer, but the working memory of a goldfish. Without persistent memory or strict boundaries, an unsupervised agent will hallucinate APIs, loop through errors, or fall victim to the confused deputy problem, where it is tricked into executing malicious commands, like deleting a production database, simply because it lacks the context to know better. Even on simple, long-horizon tasks, agents fall apart due to context dilution. As an agent processes dozens of intermediate steps, the signal of its original goal gets lost in the noise of its own scratchpad, causing it to veer entirely off track. Deploying raw, unmanaged intelligence into a corporate network is a massive liability. Until these models have a persistent, supervising layer holding them accountable, they are too erratic for enterprise use. Highly regulated industries, from banking to healthcare, are under immense pressure to automate their complex workloads using these digital workers. They want agents that can summarize patient histories or audit financial ledgers autonomously. Yet relying on public cloud models for this work is an immediate compliance failure. Sending sensitive, protected data out to an external API to be processed by a black box model violates the core tenets of data privacy laws like GDPR and HIPAA. Safely deploying an autonomous workforce requires an underlying management architecture, a centralized digital principle that enforces absolute order over every action. Think about the operating system on your computer. It manages memory, schedules tasks, and ensures applications share resources without crashing. An agent operating system performs those same functions for autonomous AI. At the center is the orchestrator layer. When multiple agents use the AI brain at once, the orchestrator decides who goes first. It sequences tasks so a background agent doesn't consume all compute while a live service agent waits. Next is the memory manager and agentic storage. By utilizing immutable versioning and persistent logs, this layer records every agent action. It maintains state across sessions, solving the goldfish problem so your HR agent remembers last week's conversation. Then there is the tool manager. Agents interact with external systems using the Model Context Protocol. It assigns unique identity tokens to each agent and runs them inside strict sandboxes. A coding agent can execute Python, but cannot access the internet. Finally, the system enforces guardrails and observability. Every API call and reasoning chain is tracked in an audit log. If an agent attempts a high-impact action, like a large financial refund, the system pauses execution and forces human-in-the-loop approval before proceeding. By layering scheduling, persistent memory, sandboxing, and governance, you turn unpredictable AI models into reliable digital infrastructure. But an agent OS can only protect you if the foundation it runs on is secure. If the underlying language model is still phoning home to a public server, you haven't actually secured your data. This implementation blueprint illustrates Treecapital Technologies' Anven AI, an architecture built to serve as a sovereign intelligence layer. The diagram outlines how organic data flow is governed through a structured cognition matrix and secure enclave protocols. As we can see outlined here, Anven is engineered for enterprise self-hosted AI. It deploys directly into air-gapped virtual private clouds on AWS, Azure, or GCP. The telemetry stays entirely within your infrastructure perimeter, resulting in zero data exfiltration. To ensure accuracy, Anven integrates natively with your internal vector databases through retrieval-augmented generation. The model cross-references your proprietary data before generating a response. If the data doesn't exist, the AI reports the absence instead of fabricating an answer. By owning the model weights and running the inference engine locally, the enterprise achieves absolute data sovereignty. You stop renting intelligence and start building a private, compounding asset. Looking at this terminal checklist, we can see exactly how an enterprise provisions this infrastructure. Teams authenticate, execute the end-user license agreement, and ingest the architectures locally using automated, pre-signed URLs. And this governance isn't restricted to massive server racks. Treecapital extends this sovereign architecture directly to mobile and embedded devices through edge-native intelligence. By utilizing highly optimized 3 billion parameter models and 4-bit quantization, Anven runs locally via the PyTorch Execute Torch framework. This allows complex agentic reasoning to happen directly on a smartphone, bypassing network latency and cloud dependency. This extreme optimization brings secure, heavily governed agentic power directly to the physical edge of the enterprise. With strict access controls and localized processing, highly regulated institutions can finally scale their AI. Hospitals can analyze patient histories, and banks can detect transaction anomalies locally, fully compliant with industry regulations. Instead of treating AI as an unpredictable black box, this framework channels massive, sensitive data flows into secure, predictable pipelines. Combining a rigid agent operating system with a sovereign language model bridges the gap between conversational chat and precise database reasoning. It provides the structured environment necessary for a digital workforce to operate autonomously. The true AI revolution isn't about making smarter models.